Today I am going to tell you all about a blockchain project named Solana, and where the price may be headed. Here is what I am going to cover in this video. What is Solana? What is the price of Sol, and where can you get it? And lastly, Sol price prediction. Solana is a fast, secure, and censorship-resistant blockchain providing the open infrastructure required for global adoption. Some impressive stats about the Solana network are that the block is usually below 10 seconds, the average fee is $0.00025, and there are 972 nodes securing the Solana network. All this makes Solana scalable, low-cost, and it is also composable because Solana's single global state ensures composability between projects. With Solana, developers don't have to deal with multiple shards or Layer 2 systems. On this channel, I have covered many projects that have solved scalability and fee issues that other blockchain networks are having, so let me tell you about the key innovations of Solana. Proof of history, Tower BFT, Turbine, GulfStream, Sealevel, pipelining, Cloudbreak, and Archivers. Let me tell you about their consensus proof of history. Traditionally, nodes in the network can't trust an external source of time or any timestamp that appears in a message. Hashgraph, for example, solves this problem with a median timestamp. Each message that is seen by the network is signed and timestamped by a supermajority of the network. The median timestamp for the message is what Hashgraph calls fair ordering. Each message has to travel to the supermajority of the nodes in the system, then after the message collects enough signatures, the entire set needs to be propagated to the entire network. As you can imagine, it is slow. To solve this, Solana uses proof of history. The proof of history is a verifiable delay function. Their specific implementation uses a sequential pre-image resistant hash that runs over itself continuously with the previous output used as the next input. Periodically, the count and the current output are recorded. The network can then be certain that real time has passed between each counter as it was generated, and that the recorded order of each counter is the same as it was in real time. Since there is a delay function, and the count and current output are periodically recorded, you may think it is slow, but while the recorded sequence can only be generated on a single CPU core, the output can be verified in parallel. Each recorded slice can be verified from start to finish on separate cores in 1 divided by number of cores time it took to generate. So a modern-day GPU with 4,000 cores can verify a second in 0.25 milliseconds. The Tower BFT is a proof-of-time optimized practical Byzantine fault tolerance. The main objective with BFT and every derivative is for the nodes to reach a consensus. Solana implements a derivation of PBFT, but with one fundamental difference. Proof of history provides a global source of time before consensus. Their implementation of PBFT uses the POH as the network clock of time, and the exponentially increasing timeouts that replicas use in PBFT can be computed and enforced in the POH itself. To render operations more manageable, voting is restricted to a fixed period of hashes, which we call slots. Their goal for slots is the number of hashes that represent around 400 milliseconds. Every 400 milliseconds, the network has a potential rollback point, but every subsequent vote doubles the amount of real time that the network would have to stall before it can unroll that vote. If you want to read more about how it works in detail, just look it up. Turbine is Solana's solution to scaling. Scaling is about bandwidth, and on most blockchain networks a node is given a fixed amount of bandwidth. And with more and more nodes being added to a network, it will take long to propagate the block information to all the nodes. Let's consider, for example, a network of 20,000 validators. The leader needs to transmit a 128 megabytes block, about 500,000 transactions at 250 bytes per transaction, to all 20,000 validators. The naive implementation would require the leader to have a unique connection to each validator and transmit the full 128 megabytes 20,000 times. There simply isn't enough bandwidth to accommodate that many connections. Turbine is optimized for streaming and transmits data using user datagram protocol only, and implements a random path per packet through the network as leaders, block producers, stream their data. The leader breaks the block into packets up to 64 kilobytes in size. For a 128 megabytes block, the leader produces 2064 kilobytes packets and transmits each packet to a different validator. In turn, each validator retransmits the packet to a group of peers called a neighborhood. Each neighborhood handles transmitting a portion of its data to each neighborhood below it. If each neighborhood is comprised of 200 nodes, a 3-level network, starting with a single leader at the root, can reach 40,000 validators in roughly 200 milliseconds, assuming each network link is 100 milliseconds on average. And to keep this short, there are measures in place, so that malicious nodes don't rebroadcast anything incorrect data. But if you want to hear more about their safety measures, read about Turbine on Solana's website. Moving on to GulfStream, it is a solution to mempool. Mempool is a set of transactions that have been submitted but have not yet been processed by the network, in other words, unconfirmed transactions. The problem is that when the mempool rises, so do the fees, and the rise results in a significant bottleneck. Solana's solution to this problem is to push transaction caching and forwarding to the edge of the network. Since every validator knows the order of upcoming leaders, clients and validators forward transactions to the expected leader ahead of time. This allows validators to execute transactions ahead of time, reduce confirmation times, switch leaders faster, and reduce the memory pressure on validators from the unconfirmed transaction pool. You can read more about how it works on their website. Sealevel, simply explained, is a runtime that can process tens of thousands of contracts in parallel, using as many cores as are available to the validator. The reason Solana can process transactions in parallel is that Solana transactions describe all the states a transaction will read or write while executing. This not only allows for non-overlapping transactions to be executed concurrently, but also for transactions that are only reading the same state to be executed concurrently as well. As for pipelining, to get to sub-second confirmation times and the transactional capacity required for Solana to become the world's first web-scale blockchain, it's not enough to just form consensus quickly. The team had to develop a way to validate massive blocks of transactions quickly, while quickly replicating them across the network. To achieve this, the process of transaction validation on the Solana network makes extensive use of an optimization common in CPU design called pipelining. Pipelining is an appropriate process when there's a stream of input data that needs to be processed by a sequence of steps, and there's different hardware responsible for each. The quintessential metaphor to explain this is a washer and dryer that wash, dry, fold several loads of laundry in sequence. Washing must occur before drying and drying before folding, but each of the three operations is performed by a separate unit, and this is what it looks like on Solana. The guiding design principle at Solana is to design software that gets out of the way of the hardware to allow 100% utilization, introducing Cloudbreak. Organizing the database of accounts such that concurrent reads and writes are possible between the 32 threads is a challenge. Vanilla open-source databases cause bottlenecking because they don't optimize for this specific challenge in a blockchain setting. Solana does not use a traditional database to solve these problems. Instead, they use several mechanisms utilized by operating systems. At full capacity, the Solana network will generate 4 petabytes of data every year. If every node in the network is required to store all that data, it would limit network membership to a centralized few that maintain that storage capacity. Solana's proof of history technology can be leveraged to mitigate this problem by allowing a fast-to-verify implementation of proof of replication and enabling a BitTorrent-esque distribution of the ledger across millions of replicator nodes around the world. Their solution is called Archiverse. At a high level, the Solana replicator network functions as follows. Archiverse must signal to the network that they have X bytes of space available for storing data. On some frequency, the network divides the ledger history into pieces to target some replication rate and fault tolerance based on the number of replicator identities and total available storage of Archiverse. Once Archiver data assignments are made, each Archiver downloads her respective data from consensus validators. On some frequency, Archivers will be challenged to prove they're storing data, at which point they must complete a proof of replication. Archivers are awarded 3% of inflation for their efforts. Now that you know about Solana and its features, let's explore what you can do with the SOL token. The average holders can stake SOL and earn SOL, and that's about it. So what is the price of SOL? Currently, the price of the SOL token has dipped below $40. The current market cap sits at almost $10 billion, with a circulating supply of 272 million SOL, out of the 494 million in total. The SOL token distribution is as follows: 16.23% went towards an initial seed sale, 12.92% of tokens were dedicated to a founding sale, 12.79% of Sol coins were distributed among team members and 10.46% of tokens were given to the Solana Foundation. The remaining tokens were already released for public and private sales or are still to be released to the market. As for where you can get it at Binance, and if you sign up with my link you can save some money on fees. If you want even lower fees you can use FTX, who have a cheaper fee structure, and if you sign up with my link below, you get another 5% off on fees. So, where is the price headed? My prediction is $175. By now some of you may know that when something talks about fixing scalability, I also turn to Polkadot. And if Solana was to rank in the top 10 coins, its market cap would be closer to the 50 billions, or in other words, a 5x. As for resistance levels, we got the recent high of $40, we also have the psychological $50 area, and the all-time high of $58. So should you buy it right now? Right now I think you should hold off on buying any coin until Bitcoin breaks above $41,000, or when it bottoms out. Check out the video in the cart if you want to know how low Bitcoin can go from a bullish standpoint. The other psychological resistance levels are the $50 areas and $100 areas, with minor resistance every $25. That's all I have for today's video. If you enjoyed this video, don't forget to like and subscribe for more content. And as always, do your own research, practice good risk management, and once again, I am not a financial advisor. With that being said, I'll see you in the next video.